welcome back. In this lesson, we are going to learn about layered tasks. So let's look at the agenda. We will be learning why we have to do layered tasks and different 13 layered tasks. Then overview of the layered tasks 1 to 6. Why do we need layered tasks? Let us understand this with the help of an example. Let's say we have a computer C. It is connected via the transmission medium to a computer C. Let's write it as CB and this one is CA. So this is the sender computer and this is the destination computer. In order that this sender computer sends a data which is divided into various parts D1, D2, D3, etc. It passes through the transmission medium or channel and reaches the destination. Now, this task of sending the data from one computer to another requires lots of functionalities to be performed. It is not an easy task. There are lots of tasks that must be performed. So, these tasks are segregated into different layers. That is why it is called a layered task. There are 13 layered tasks. These tasks are also known as the communication task. Which must be performed by the two computers through the nodes of the network via the transmission medium for data transfer. Now let us see what are the different 13 layered tasks. Number 1 is transmission system utilization. Number 2 is interface. Number 3 is signal generation. Number 4 is synchronization. Number 5 is exchange management. Number 6 is error detection and correction. Number 7 is flow control. Number 8 is addressing. Number 9 is routing. Number 10 is recovery. Number 11 is message formatting. Number 12 is security. And number 13 is network management. Let us understand layered tasks 1 to 6 in this video. First, we concentrate upon task number 1 and 2. Task number 1 is transmission system utilization. Now, what is the meaning of transmission system utilization? We have a computer here that is a sending computer. This is the transmission system through which data passes to the destination computer. Now, resource sharing is very much important. Now, what is resource? Resource is the frequency or the channels that we call in terms of data communication, or it can even be time. So instead of sending one message through the communication link and using it for the entire duration of time or using a single frequency of transmission, we can divide this resource into several different parts. Like we can divide them into several different time slots for sending data 1, data 2, data 3 at the proper time slots, or even we can send different data having different frequencies, like data 1 having frequency F1, data 2 having frequency F2 and so on. In that case, it is frequency shared. So we can use the technique which is known as multiplexing. Multiplexing means large number of data are fed to this device which is called a mux. And through a single communication link, all these data like D1, D2, D3, etc. are interleaved and passed through the transmission medium. This is called multiplexing. So in this way, we can share the resource among multiple devices and multiple messages. Next, we go to interface. This is the physical connection of the device to the transmission system or transmission medium. We can have the Ethernet port through which the computer can be interfaced to the transmission medium. In that case, we can use RJ45 connector. So this is interface. Next, let us understand task number 3 and 4. Task 3 is signal generation. Once the computer generates either 1 or 0, it has to be passed through the transmission media in the form of waveform. So waveform is basically the signal that is generated, and we call it electromagnetic signals. This electromagnetic spectrum has a wide range of frequencies starting from few hertz to 10 to the power 20 or 24 hertz. Now, based on the transmission medium through which the signal is passing, the signal form intensity and frequency must be taken into consideration while converting this data of 1 and zeros into electromagnetic signals. So this is known as signal generation. Next, we come to synchronization. This is task number 4. Synchronization means the receiver should understand the start time and end time of the data that is being sent by the sender. So this is known as synchronization. Basically, synchronization is related to timing match between the sender and the receiver data transmission. Next, we go to task number 5 and 6. Task number 5 is exchange management. Exchange management means for data transfer, both the sender and the receiver must cooperate. What is the meaning of this? When the sender is sending some data, the receiver must be able to accept it. The sender is sending this data and the receiver has to accept this data. Let us understand with the help of telephone communication, which is analogous to circuit switching. Suppose a sending station, we also call it the subscriber. The sending subscriber wants to connect to the receiving subscriber. In this case, what happens? The first step is to set up the path. That means the sending subscriber is ringing the telephone set of the receiving subscriber, and the receiving subscriber picks up the telephone set. It is then that the path is set up. Next is data transfer. So once the path is set up, data transfer can take place both ways. Number 3, if any one of the parties want to hang up, then the path should be terminated. So path termination. So these are the 3 steps that must be followed for data transfer between two entities, and this is known as exchange management. Next task is task number 6, and it is error detection and correction. During data transfer, let's say we are transmitting data 101101 from the sending end. So these are the pulses that will be transmitted like this. Okay. Now this is the sender side. Now we must understand that the signal is weakest at the channel. Signal is weakest at the channel because it can be hit by noise. And when noise hits a signal, specifically when noise hits digital signal, the zeros can be changed to ones and vice versa. So at the receiving end, let's say we are having a receiving end, and instead of this data, due to noise, the data may be changed and we may have 1 0 0 1 0 0. Let's say 1 0 0 1 0 0. So there are some errors. You see, the first bit has been transmitted properly. The second bit has been transmitted properly. You see, there is error in this bit. 1 has been changed to zeros. Again, this bit has been transmitted properly. This bit has been transmitted properly. Again, there is error in this bit. So these two are erroneous data. So whenever data reaches the receiver, there may be some error, and in some cases there are some applications where error cannot be tolerated. Like when file is transferred from one computer to another, error is not tolerable. So there must be proper mechanism by which error may be detected, and if necessary, it may be corrected at the receiving end. So this is known as error detection and correction. So this is task number 6. To summarize, in this lesson, we have learned why do we need for layer tasks, what is the need for layer tasks. We have learned about 13 layer tasks, and we have got an overview of 1 to 6 layer tasks like transmission system utilization, interface, signal generation, synchronization, exchange management, and error detection and correction. Thank you.